Welcome to what will likely be one of the last videos in Section 4 of the Scrape the Planet course. Section 4 has been a blast. We solved a really difficult problem in the last couple of videos in the Kevin Bacon problem on IMDb. In this video, we're going to take a step back from that. This is actually going to be the video that I use on YouTube to kind of show what this class is all about. And that's because we're going to take a step back and develop a quick, relatively simple spider from scratch. Now, if you haven't watched the course yet, or if you're watching this on YouTube and haven't heard of the course, this is going to be part of the Scrape the Planet course on Udemy. I will obviously leave a link below. If you're watching this and it's been a couple of months since the course has come out, it very well might already be uploaded on YouTube for free. But if it hasn't already, you can follow that link and you can enroll in the course and see what else we've been covering. The last spider that we created was incredibly complex. This one is going to be quite a bit simpler, and it's really going to focus a little bit more on the foundations that we've talked about before. So, what are we going to be doing? We're going to be spidering. We're going to be writing a web scraper spider thing for Wikipedia. Now, if you watch the last couple of videos in this course, you know that one of the best targets for a web spider, as opposed to a scraper, is a web page with tons and tons of internal links. And that is because, like we had said before, spiders are all about finding connections between objects, and the more links you've got on one page, the more links you can actually create within your data, and the more your spider can crawl. Think of a web. If you've got a web that just has one strand this way and one strand that way, it's not very interesting. But if you have tons of strands this way and tons of strands interlinking across them, then it's a much more interesting web, a lot more useful for the spider, and you're going to catch more interesting things. So we're going to be creating a spider for Wikipedia. It's not going to be doing anything just unbelievably complex. Essentially what we're going to be doing, and I'm going to write this stuff out here, is we are going to be pulling down, we are going to be pulling down the page title, the page link, the page links, or length, the page links, so that's the links to other pages, obviously. I think that's about it. We'll talk a little bit more about the data structure here in a second. We're going to be building out the skeleton code really quick, kind of doing that like in the quick and dirty method, because if you've been following this course already, or if you've kind of watched a couple of videos from this course already, you kind of know how to write skeleton code for spiders and scrapers. So I'm not going to spend too terribly much time on that, since most people who have been following this course already know that. So let's get our imports down. That's obviously easy. Sys, request, #lib, time. Obviously we'll need beautiful soup. Import beautiful soup. And as usual, I'm going to import it as BS, which is funny every time I write it. Psycho PG2, probably mispronouncing that, and I'll probably have somebody angry at me in the YouTube comments saying it's I don't know, pronounced some different way. All right, so we're going to create a function. Obviously we'll have main, so we'll go ahead and write out that def main, and we'll just return empty here. We're going to be running this within a permanent loop, or an infinite loop more than likely, so the return doesn't matter too much. Name equals main, and we'll run main. All right, so basic, kind of boilerplate code there. We're going to create a function to handle the connection to our DB. And that is going to take in an IP, database name, a username, and a password. So all of this we're going to throw within a config file. I've already got the config file written out. Not too much of a point in showing you that, just because it's going to have all of this information. Nothing sensitive or anything, because obviously it's an internal IP. and a piece of infrastructure I don't actually use. But it's not interesting, so I'll show you how I'm accessing that here in a second. I'm going to access it within the main function. Then we're going to have a pull page function. And that is going to be our main scraping function of this spider. I'll explain that in a bit. So we're just creating our skeleton code here, just all of the functions that we are going to have. We're going to have a function to insert into the DB. So def insert DB. We'll have an object to insert. We'll have a connection object, and we'll have a cursor object. And we'll return from there. And we'll have a check DB. And what that is going to do is it's going to actually check to see if an object is already in the database. And we won't worry about default settings there. Alright, so we have our functions and our skeleton code here. Let's waltz into our main function. Now here's how this is going to work. We are going to take a wiki link, and I'll show that here in a second. We're going to take a wiki link to start with as a root node. And I'm going to make a note here, internal, and I'll explain that here in a second, as input from user for root node. So try except. This is going to be root node is equal to sys.argv1. We want the first, or basically the second input variable, because with sys, the first input variable is always the name of the script. So we want the second one. And then if we don't end up getting that, print, please run the script with one internal Wikipedia link. All right, fairly simple there. We're going to return if we don't get the right number of variables. Return. Promise I'm not drunk. I just can't type on this new keyboard. I don't know if you've noticed, actually, since the class started, I had a really loud keyboard, and it was just super obnoxious, and I actually bought a new one because I needed a new one to begin with, and because I could actually, like, hear it in my dreams. It was the most ridiculous keyboard ever. Alright, so after we get the root node, we're going to connect to our database. So cur con is equal to connect db, and we obviously need some information first. So config is equal to open, and we're going to keep this within our current directory, config.txt. And we'll wrap this in a try block just because it's probably the right thing to do. Except print no config file found. And we're going to return. Just because I'm nitpicky, I'm going to change these to my typical format for error messages. Not necessary at all, it's just kind of how I always write out error messages. Okay, so our IP is going to be equal to config, well, let's just get the lines first. Lines equal to config.readlines. That's a function. And then we're going to close config out. There we go. Guess we should put this in here. Indent. So IP is equal to, I think that should be, let me open up my config file here just so you can kind of see what it looks like. Let's see. Well, I say that. I'm trying to open it, I promise. Let me drag it over from over here. Here is our config file. There we go. So the IP is the first line. 0. The username is the second line. The database is the third line. And the password is the fourth line. There we go. So now we can pass all of those into ConnectDB. IP equals, let's see how I passed it up here. IP, database name, username, password. IP, database name, username, password. IP, DB name, username, password. So that'll get us our database connection first. Let's go ahead and let's see. To check our database, we need to actually create the object. And we're going to get the object from pull page. So root obj is equal to pull page at root node. There we go. And check DB root object. And I'll explain all of this here in a second, because obviously all of this isn't going to do anything. It's just skeleton code for right now. Root in, and that's going to be a Boolean, hopefully. And if not, root in, insert DB root object. So here's what this is doing here. Basically what we're doing is we are creating our initial root object by scraping the page that the user gave us as input. We can close out this right here. So we're going to scrape the page that our user gave us as input just right off the bat. We're going to check to see if it's already in the database. If it's not, we're going to insert it into the database. We're going to do all of that before we actually enter into the main infinite loop. So we'll create that here while true, the classic way to create an infinite loop. Links is equal to root object at links. And then for link and links, q dot, well, let's see. I guess we should check and see. I'm trying to think of the best way to do this. So basically, I'll walk through it and hopefully understand it here in a second. All right, let's do this a little bit simply. So we're just going to grab the root object. We're going to create a queue. We're not going to worry about whether or not it's in the database right now. Basically, worst case scenario, we just get a basically we get an error saying that it's already in the database, and that's not going to really make a big deal. So we've got our queue, that's a big deal, and we're going to automatically append our object to the queue. So let's see, append root obj. Let's only append the links. Link, there we go. So for link and links, we're going to append it. Append link. And then, let's see. Cur node. Let's not do it that way. Okay, so now that we've got the queue, we've appended our root object to the queue. Let's go ahead and enter our main loop. So we're going to print out the queue size right off the bat, just because that's a cool piece of information to keep track of. And that is length of, ooh, can't spell queue. queue. Right, so right off the bat we're doing that. We're going to set our current node, 0. So that's just going to be the first item within the queue. And then we're going to create our object. Object equals pull page. So we can go ahead and get rid of this because that's just going to scrape the first page twice. And we'll just throw in root node instead of root object. So the object is equal to pull page at current node. Fairly simple there. And we're going to check to see if it's in the database or not. We're going to pass in the current object, the connection object, and the cursor object. Simple stuff. So let's explain it thus far. Right here at the top, we are going to take in an internal link to a Wikipedia page. Let me show you what that actually means. Let me open up a new page here. Alright, so now that I've got the actual web browser open, let's go to a Wikipedia page. So let's just do Wikipedia Tiananmen Square. That's always just a light Wikipedia page to browse over. So once we click on this, we're going to basically just grab this part of the link. This is the internal portion of the link. We know that we want to only be scraping wikipedia.org. We don't want any other targets to be in scope. I'll show you how to keep those things in scope here in a bit, but this is going to be our user input. We're going to start here. So right here is where we're going to grab the initial root page of the Wikipedia. So obviously down here it's going to tell us if we haven't given that input correctly, and we're going to read in our config file. The config file is just going to contain information to our database. That's a fairly typical way to access a database instead of having it all just hard-coded into your code. Not great practice to do, but instead we put it in a clear text file, which also isn't great practice to do. So then we're going to create our database connection using that information and initialize our queue. Now a queue is a first in, last out, or a first... Now a queue it can work in a couple of different ways, and I'll show you how we're going to be using it. We're basically just going to be using it as an array that we're going to use basically to append the future items that we're going to process. So that's why I'm printing out the queue size here. Here in a second, we're going to start appending new links that we're going to, basically that we're going to access and to scrape later. We're going to add those to the queue and run over it basically infinitely. And the reason why it's infinite is that for each page that we scrape, we're going to keep adding more items to the queue. So obviously it's going to grow exponentially very, very, very quickly. All right, so we've checked to see if our current object is in the database. After that, we're going to use that logic. So if in db, so that's obviously going to be a Boolean. Check db returns a Boolean. And pull page returns an object. So make sure that we keep track of that. And the queue is a list of links, not a list of objects. If we get our data types mixed up, then our program logic is going to be spaghetti, and we don't want spaghetti. All right, so we're going to print out basically a message that says that the object with link obj link was already in DB, not adding links to queue. All right, and then if it's not in the database already, if we haven't already processed it, And let's just do else here to be a little bit more explicit with the way that we write our code. Print. We're writing these print statements just to kind of keep track of our logic for right now. Object with link, obj link was not in DB, adding, and we'll print out the number of links that we're going to actually print. Length of object links. So we can kind of keep track of what our data is supposed to look like. So our data object is supposed to have dot link, which is a hyperlink to objects page, obj dot links, which is array of links contained in page, array of internal links. So we're going to do the checking within pull page. Basically, the check and pull page is going to make sure that the links that we are returning within the object are actually internal links. They're not links that are going to take us outside of Wikipedia, because that's not what we want. So we've got an array of internal links contained in the page. We're also interested in the length, length of page. That's just kind of like an interesting metric to track. You can, look through like what the average size of, different pages are. Relatively interesting, but, not like the end of the world if we decide not to grab that information. And I believe that might be it. Well, we might add to that here in a second. But I want to say that, and the title, duh. So obj.title is the title of the page. Obviously, interesting information to keep track of. And I believe that's actually it. So if it's not in the database, then the object with link was not in the database. That's going to be what we print out. And we're going to insert that object into the DB. So res is equal to insert DB, then object connection cursor, and print res. That's going to tell us the result. Let's just do this. Result of insert DB res. So that's going to keep track of whether or not we were able to successfully insert it into the database. And then for link in object links, we're going to append them. So, q.append link. Now, after all of this, we obviously need to take that object off of the queue. Otherwise, we're going to keep processing the exact same page over and over and over again. So basically what this does is, if our array currently looks like this, so before, we've got foo, bar, baz. After we do this, it's going to just remove the first item. It's basically saying we want every item after or starting at 1 and after. So what this means is this is the starting variable, and it's inclusive, which means that it includes the variable that you're referencing. So this being 1, that is the second item within the array. And if you don't put anything after this semicolon, then it's going to take everything after that. So after would look like bar baz. So that's essentially what that does. You want to take that item off because that is the item that we're currently processing. Otherwise, after we loop back through this, we are just going to set current node equal to the exact same thing. And we're going to keep reprocessing the same page over and over again. And that's obviously not interesting. Time.sleep, because we don't want to hit Wikipedia with tons and tons and tons of traffic without sleeping and giving them a break a little bit. All right. So now we can start filling in these functions that we've been referencing. Obviously, that's fairly important. We're going to start with the connection to the database, because that's honestly like the easiest one. So let's go back up here to connect DB. This is going to be a very, very simple function. So connection is equal to psql.connect, and we are interested in the database equals DB name, user is equal to username, password equals to password, host equals to IP, and port, I believe you can leave this blank, but I like to put it explicitly just in case you want to change it, 5432. Cursor is equal to, well, actually we're going to do something special here, and I'm going to explain it here in a second. And we're only doing this right off the bat because I found out through testing, set underscore session auto commit equals true. So I found out via testing that if you manually commit, for some reason it just throws tons and tons of errors. And by commit, if you haven't watched the last couple of videos where I kind of explain this, committing with Postgres, or at least with PsychoPG2, is very, very similar to committing with Git. So with Git, you make changes to files, you add them, you basically create a cursor object, or track them as changes. So you use git add in order to add those changes, but nothing actually changes until you commit them and push them upstream. So PsychoPG2 also has a commit. Basically, you can stage all of these different changes you want to make to the database, but none of them actually happen until you commit them upstream. So that's what auto commit equals true does, is basically as soon as I run a query that would change things within the database, it goes ahead and commits that instead of me having to explicitly commit it. I don't know why there are errors with the .commit function. It's probably because I don't know databases very well and I don't know Postgres very well, but I was just constantly getting errors with that, and auto commit fixed all of them. So we're going to go ahead and do that. Just kind of trust me. You probably should read more into it. I'm probably going to after this class is over, but definitely look more into that and see why exactly commits, throws bunches of errors. And then we'll create the cursor object. Now, just like I have in the past, we're going to create an initial query that creates our table if it's not already created. And I'll explain this query here in a second. Right. And then title. Alright, so let me walk you through this query. We're using Postgres in this class. If you're watching this on YouTube, we've been using Postgres pretty much the entire time. And I'll give you the same disclaimer that I did before during the class. I am not a database expert. I frequently screw it up. And if you're trying to take this class because you want to become a database expert, you're probably not going to get a refund, but you're also not going to be satisfied. So just go ahead and understand that this course is on web scrapers, and I chose a database technology that I've used before and that works. I'm not going to take any security measures at all, because you should not ever put anything from this class on prod. You need to secure it and actually put some decent effort into it. This class is basically, the purpose is to teach you the foundational knowledge and to give you the knowledge that you need to go on and create things that you're actually going to put in prod and up on the internet, and actually have either somebody else secure your database or you actually study how to secure databases. But for right now, I'm not going to go through the effort of learning database technologies like Postgres to perfection, because I'm not a DBA, and I don't plan on ever being a DBA because that sounds really boring to me. But yeah, don't ever put anything from this class on prod, because I'm literally using password as password. I mean, that should be a dead giveaway. So if you decide to put a Postgres database up on prod with a default password that bad, I don't really feel bad for you. That's your own mistake. Okay, so what this query does is we're going to run this query against our database that we have created in a class before. I think that was 3 sections ago, something like that. And we're going to run this query immediately against that database as soon as we connect. And basically what we're trying to do is we're trying to make sure that the table wiki_data, is created on our database. And if it's not, it's going to go ahead and create it with our data format. So this UUID is the only real difference from what we talked about before. I'll explain that later, but essentially it is a unique identifier that is going to be present in every row in our database. It's going to be a way of making sure that we don't constantly store the same exact data over and over again. Very, very common across essentially all databases that you're going to see to have a UUID. That is going to be of type text, which is just a string. It's going to be not null, so we have to have this item. And it's going to be our primary key, which means that it is a unique key for each row in the database, and it's not supposed to ever repeat. Then we have our link, which is going to be just the link to our page, also string, also required. The length of the page, which is an integer, also required. A list of text objects that represents our links within that page, also required. And the title of the page, which is a string, also required. We're requiring every piece of data within this row just to make sure that we are in fact gathering it all. If we're not gathering it all, then we've got an error somewhere in our scraper that we need to check out. And we're going to run that, cur.execute, initial _ query. We're not super worried about the return here, the return of that function at least, but we do need the connection variable and the cursor, the connection object and the cursor object. So, very, very simple there. All we're really doing is connecting to the database and making sure that our table is created. So then we're going to move on to pull page. This is like the meat and potatoes. This is the actual scraper that we're worried about. We're going to go ahead and grab our data format from down here that we created and throw it up here for reference. Because this is the format of the data that we're trying to actually pull from each Wikipedia page. So, let's run through this. The link is easy. We've already got the link. So obj dot, let's just create the object first. And we're going to throw the link in is equal to page link. So that's simple. That was, essentially given to us. Now we need to actually scrape it down. So requests.get, and we're going to append Wikipedia to the front, wikipedia.org plus page link, because every link that we're actually going to append here is going to start right here. So if we get rid of wikipedia.org, this is going to be what we actually store within all of our objects, what we store within the database. So we need to make this an actual usable link here in order to run it through requests. So that's going to be in rec, or we'll call that res because we're interested in the result, not the request itself. So the res text is equal to res.text, fairly simple there. That is going to be the actual source code of the page. In other words, this bunch of malarkey is what we actually want to run through and parse. And we're going to use a wonderful piece of technology called Beautiful Soup. Soup is equal to BS, which is our beautiful soup import up here. Let's go ahead and minimize that. We're not interested in it anymore. And we're going to pass in res text, and we are using html.parser. That is the actual parser that we're going to use to parse through res text, because res text will be an HTML page. That's the kind of page that we're pulling down here. So now we need to get out the link we already have. So let's go ahead and put an X next to there. We need the links in the page, the length of the page, the title, and the UUID. I'll show you how we're going to create the UUID here in a second. We're actually going to create it last, and you'll understand why. Unique ID. All right, so I think the title is going to be the easiest part to get. So obj at title is equal to, and let's inspect this page right here. If you want to inspect a particular piece of information, you right-click it in your browser, press inspect, and that's going to show you within the HTML code what it looks like in there. So, as we talked about in the first couple of sections where we covered Beautiful Soup, the best possible situation is for you to be interested in a piece of information on a page that has an ID. And here's why. The best possible situation, as we talked about before, if you're interested in a piece of data on a page, is if that piece of data has an associated ID. And here's why. We're going to be parsing through this data using its attributes, so using its classes, using its IDs, using its tag types in order to parse through it and search for the information that we actually want. An ID within HTML is unique, which means there is only going to be one object on this entire page with the ID of first heading with a capital H. This means that we can very, very easily find it on the page because there's only going to be one. So we can go ahead and say that obj title is equal to soup.find, and we are looking for, one moment, an H1 with an ID of first heading, and we're interested in the text. Basically what that means is once we run find, we're going to get this entire piece, this entire tag basically. We're only interested in the text within it, so the 1989 Tiananmen Square protests and massacre. So that's what we're actually interested in. So we're going to run .text in order to just grab the .text within that tag, instead of grabbing the entire tag itself. So that was easy. That's going to be how we actually just grab the title of the page. So next, we're going to grab the length of the page. Also very easy. Length is equal to the length of the page.text. So like I said, that's not, well, not page.text, the res text. There we go. All right, so that's also fairly simple. It's not a super interesting piece of information, but I figured it was just kind of like another thing that we could very easily add to our database. And it might be interesting just to kind of scroll through and like look for what the longest page that you've scraped is, and just kind of like track that by, you know, just it's an interesting metric. I don't know. Honestly, it was something that I was just kind of like interested in. So the links are going to be what kind of gets a little bit more complicated. But let's go ahead and create the UUID first before we get into the links. So the UUID, since it's supposed to be unique, I'm going to use the MD5 hashing algorithm, and we are going to pass in is equal to hashlib. Hashlib is a library that contains all of the different kinds of hashing libraries. I think it's got MD5, SHA-1, SHA-256, all that kind of stuff. So if you're not familiar with hashing libraries, basically what the creation of a hash is you're taking a string and you're passing it to a function. And what that function does is it takes that string and turns it into another string of completely randomized variables. So completely randomized, like text and numbers and all of that. And I'll show you here in a second an example of that. But the purpose of this is every single time I take one string, so if I take bar and pass that into the MD5 hashing algorithm, it's going to spit out a really long string of letters and numbers. If I pass in bar again, it's going to return the exact same unique string of random letters and numbers. But if I pass in a different string, if it's bar with a space after it, then it's going to give me a completely different randomized string of letters and numbers. So I say randomized, it's technically not random entirely. Like, theoretically, there are hash collisions, but that is completely outside of the scope of this entire, like, course. But I could just kind of see some, like, jerk on YouTube being like, well, technically it's not random because blah, blah, blah. Yes, it's not random, but it's random enough. Anyways, we're going to pass in, so we're going to use the MD5 hashing algorithm. We are going to pass in the title appended with the page link. We are going to encode that, because the MD5 library requires a specific kind of encoding, so you have to encode it before you pass it to that library or that function. And we are interested in the hex digest, which is just the raw string representing our hash. So we're going to print this out just so I can kind of show you. Hash for link, page link. So let's do, okay, so this is supposed to be obj title is obj UUID. And these have to be double quotes because it's going to throw a fit. All right, so this is going to actually print out that unique ID for the page. And we'll tab that over so it kind of stands out a little bit. So we've got our UUID, we've got our title, we've got our length. So let's go ahead and mark those off the list. Oop. Without erasing them. We've got our title, and we've got our UUID. Now we just need to process the links. Now it's going to be fairly easy to grab all of the links on the page, but that's not necessarily exactly what we want. So let's do hrefs is equal to soup.find, press Windows key, all, and we're looking for all A tags. All an A tag is, in case you're not familiar with HTML, tons of people probably aren't, every single link on the page, so every single hyperlink, the blue things that you see with underlines, on most pages at least, are within an A tag on a page. The href is the link to the page that it's referring to, then it's got the title, and it's got an internal piece of text that you actually read on the page. It's highlighted in blue and all of that fun stuff. So here is the issue. Since we're going to be appending these to the queue, we only want internal web pages, meaning we only want pages that are going to return to Wikipedia. So obviously we've got /wiki/wiki/wiki, but if we go down, for example, to the bottom of the page, way on down there, let me kind of minimize this a little bit. If we look at the external links, for example, this one's going to be explicitly external. That's going to take us to china.usc.edu. We're obviously not trying to go there. This one is going to take us to a web.archive.org page. We're not interested in that. We are only interested in internal web pages. We're also only interested in web pages, not JPEGs or different picture files, video files, things like that. So there's a fairly simple, maybe overly simple way to solve this. We're going to loop through every href on the page. So for link and hrefs, we're going to wrap all of this in a try catch, or try except, sorry. I'll explain why here in a sec. Href is equal to link at href. So that's going to take the actual link to the page out. Let me show you that here. So this is the actual link itself. We're not interested in this archived. We're not interested in the nofollow or the class or anything like that. We are just interested in the href part of this tag. So that's going to extract that. And we're going to run this through a very long if statement. So we are looking for if wiki is in href, and we're going to make this just a very long piece of the and statement, http not in href, and https not in href, and www not in href. This is probably overly verbose, honestly, but I'll explain why I'm doing it this way here in a second. There are actually two different portions to this, and I'll kind of pull them all out. So www not in href, and .org not in href, and .jpeg not in href. So basically what this is saying is we are only looking for pages that have wiki in them, and they are not external pages. So all of the external pages are going to contain the string HTTP or HTTPS. Now, 100% up front, this is also going to weed out pages whose like titles have HTTP and HTTPS. So instead we could do something like that. This should only weed out links. So basically all of the internal pages, if you look within the source of this page, all of the internal links, let's look at this one, this should be internal. All of the internal links aren't going to have the protocol type in them. They're not, or the protocol or the HTTP method. So it's not going to be HTTP or HTTPS. That's not called the HTTP method, but the actual word is slipping my mind right now. It's just going to be /wiki because it's an internal page. It knows that it's going to be wikipedia.org/wiki/demonstration people. So it doesn't, we need to basically screen out anything that has the HTTP or HTTPS, such as all of these external links. So this one obviously explicitly says it's external. This has HTTPS:// in it. This one as well. All of the external links should have that in it. Then we're going to make sure it doesn't have www in it. That's probably not necessary. Like I said, overly verbose. .org. Sometimes you'll run into an internal Wikipedia page that contains the word wiki in it, but it also is a wikipedia.org page that takes you, I think, to their donation page was the one that I kept running into. And we're also making sure that we're not grabbing JPEGs because we're not interested in pictures. Probably could add like PNG, GIFs, things like that in there, but we're not super worried about it. So if this is the case, then we're going to append it to the links. So obj at links dot append href. So that means that we are in fact interested in this. Let's go ahead and instantiate obj at links is equal to that. So that should work. It's not the way I normally append to objects, but it'll do. And if there's an exception, basically what this was right here, I was running into a bunch of A tags that for whatever reason didn't have hrefs. None of them were interesting A tags. I don't know exactly what they were. I wasn't super interested in finding it out, but basically they were ones that we weren't interested in. So if that's the case, then we're just going to continue. And after all of this runs through, we've got all of our links, we've got all of our titles, we've got all of our UUIDs and page links and all of that fun stuff. We're just going to return the object. Very, very easy here. So that is like the lion's share of the work. Like that's the vast majority of what this is going to need to do. Basically everything else after this is just going to handle inserting the information into the database and checking to see if the information is already in the database. So I'm going to run through that fairly quickly here. Since it's basically just database querying, which is like the least interesting part of this course, and also the part of the course that I'm the least like qualified to talk about, honestly. We're not going to worry too much about like taking a ton of time to make sure that this is right. So I'll explain it, but I'm going to explain it like fairly quickly. So query is equal to insert into Wikidata. It's taking the link, the title, the UUID, length, and the links. And then values, which is going to be what actually passes in the values with string formatters, 2, 3, 4, 5. So it should be right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Basically, the numbers just have to match up, and obviously the order that you pass it in has to match up. So we're going to run this through a try except to make sure that it fails well. So cur.execute, we're going to run the query, and the pieces of information that we're passing in are the object at link, the object at title, the object at UUID, the object at length, and the object at links. Fairly simple stuff there. One of the issues that I ran into very, very quickly was I decided to leave this S off. So I was basically passing in object link and object link twice, and it was expecting me to pass in an object array here when I was just passing in a string. I spent 45 minutes trying to debug that. Was absolutely infuriated when I found out that it was just a fat finger. So make sure that you don't fat finger, and if you do, you find it fairly easily. So we're returning success here, because if we successfully execute this, we don't get any errors, then it's going to return. Obviously, we're going to be successful, and we're not worried about anything else after that. So then we're going to accept, and this is going to be if duplicate key in STRE. Obviously, we need to actually pull this out. Accept exception as E. Can't tell you how many times I've written that particular string before. So if the result of this is a duplicate or has the string duplicate key within it, that just means that we're trying to insert something into the database that was already there. So we're not interested in like failing or anything like that. That's still successful. We're just going to print out key already exists for link obj link. There we go. And we're still going to return success. Now, if we have a different kind of error, then we're just going to return fail. And we're going to append the type of error. Since we're printing the result out, we'll actually see what kind of error we got here. So that's going to be our insert database method. Very, very simple. Just, let's see, 13 lines of code, most of it empty space, and a lot of it just this query. So very, very simple. We don't really need to spend too much time running back through it. So we'll go ahead and minimize that. Now for our last method, the checkDB method. All this is going to do is tell us whether or not this particular piece of data is already in the database. So we're going to query, we're going to create our query here. We're going to select UUID from wiki_data, where UUID is equal to the string. And the string that we're going to pass in is just the UUID string within the object. So cur.execute query and the UUID. Now, funny quirk about PsychoPG2 at least, may not be present in 3, but for some reason it requires tuples whenever you're actually running the execute method. Don't know why, probably should look into why, haven't looked into why, have known about this particular quirk of PsychoPG for quite a while, haven't looked into it, don't care that much. But just know if you ever get like a weird error and you're only passing in one string within the arguments to a query, or the I guess, yeah, it would be arguments, the parameters to a query. Just know that for whatever reason, it's got to be a tuple, so you can just insert a comma here and have nothing after it, and it's just perfectly fine and dandy. So, rows is equal to cursor.fetchAll. And what this is doing is it's going to grab all of the results of the query that we just ran. Now, we're not interested in those results. We're interested in whether or not those results exist. So, all we have to do here is return the length of rows greater than 0. Meaning, if there is one result, if there is 1,000 results, it better not be, because that would mean that our unique ID isn't working, then it's going to return true here. If there is only 0 rows here, if there are no rows, if it just doesn't fetch anything, then it's going to return false. It's like the simplest possible way to write this function. I absolutely love the way that I wrote it here. Every once in a while, I write code that I'm proud of. It happens very rarely, but when it does, I like to brag about it. All right. That might be it. I'm going to run this, see if it works, and I don't believe we've forgotten anything. So let's go ahead and run it. Let's just give it a try. The best part about developing software is the fact that you can just test just absolute garbage code over and over and over again. So let's open up a terminal, and we're going to clear it out for luck. Always clear out your terminals for luck. And we're going to run S4, well, gotta run it with Python. S4 underscore P7 underscore new, I hate the name that I gave this, .py with our glorious, I shouldn't say glorious, with our Tiananmen Square page. I don't know why I chose that one in particular. I think I was just feeling edgy, but I'm going with it. Can't open file. Oh, we're not in the right directory. Why are we not in the right directory? That's weird. Sometimes VS Code just poops the bed, but now I'm at least in the right directory. So we're gonna run python./s4 p7 new.py with this string. Let's run it. No config file. That's weird. There should be a config file. Open config.txt. Config.txt is right there. Oh, it's because real dines is not a function. Read lines is probably what we wanted. So let's clear this out. Let's get rid of this here. Let's clear it again for good luck. Always clear again for good luck. And run it. Unknown host. Apparently my database is down. Let me restart that and I will be right back. Okay, so fun fact. For whatever reason, a lot of times text files can insert different artifacts that completely screw up parsing. So my dumb programmer brain should have known this. Basically, it's trying to read in 10.0.0.8 with a new line appended to the end of it as an IP address. Obviously, that's not a valid IP, so we're just going to use strip at the end of every line here, and that's going to get rid of those pesky new lines for us. Probably a better way to do this, but I'm doing it this way. Now, let's clear it again for good luck, clear it again for good luck, clear it again for good luck, and now we should be good to go. All right, we are in our loop and immediately gets an issue. So we're trying to, we've got this reversed. Concur. So if you're returning in one manner, so we're returning concur here, needs to be in the exact same order here. Otherwise, it's just going to get everything just mixed up. So let's try this again. Oh, we didn't clear again. There we go. We're inserting into the database, and now we have a huge queue. So now we're marching through our queue. Right, and it looks like it's running over the exact same page over and over again. Huh. Oh, it's because we have to reassign this. Can you tell it's late? Alright, so now we're actually reassigning it, so now the queue is equal to Q1 and after. So I think there I just got confused because I was explaining it and then just completely forgot to actually do it correctly. So let's clear again for good luck, and now run it. Now we should actually be knocking off the first object of the queue. List index is range. Oh, it's because our initial root is already in the database. Let's clear the database out. Okay, so we need to connect to testDB and run that. Exit. All right, so it needs to start with an empty table here because I didn't properly write the logic here because I was trying to write something like quick and dirty. Now we should run it perfectly. Get a success there. All right, so now our queue is actually knocking off that first item there, and we're running through links. So after just tons and tons of recording or tons and tons of programming mistakes, we actually have a successful spider. Very, very exciting there. We're going to call it, and this is actually printing out those hashes, so you can kind of see what I'm talking about with an MD5 hash. It's just a long string of randomized letters and numbers. And as you can see, we're also getting PNGs, so we probably need to go back up there and screen out our PNGs. Now, tons and tons of problems with the spider. Again, do not use this in prod. You're not really gathering super useful information. It's cool because you're able to do it on your own, and you wrote your own successful like spider, and that's awesome. But you know, you're not gathering perfect information, and you're not gathering it perfectly. This wouldn't be something that I would put in prod. There's just tons of issues with it. Like, for example, this queue is going to grow indefinitely, and it's going to start really eating into some RAM. Once it grows to like hundreds of thousands of different links, you're going to really start running into some issues with RAM. There's going to be a lot that we talk about in the next section, in section 5, that actually is going to be fairly relevant to how to get around those kind of issues, like the RAM usage issues with like ever growing queues, for example. That's something that you can actually use when you implement queues within databases instead of implementing them just in memory like we are right now. So that is an example of something that we're going to cover in the next section of this course, in section 5. I will save the intro to section 5 for the conclusion of section 4. This section has been awesome. We've now written 2 very successful spiders that solve cool problems, or at least create cool problems to solve. And it's been super exciting. So yeah, I'll save the intro to the next section for the conclusion of this section. If you're watching this on YouTube, thank you so much. This was an absolute blast to produce this entire course, this particular episode, like in particular. If you're watching this while the course is still on Udemy, please, please, please go and check it out. You don't have to watch the entire thing, you don't have to buy it, but I did spend a lot of time putting this together, and if you do end up signing up for the course, it would be really awesome if you left me a course review. Course reviews are very, very helpful in letting me know what I did right and what I did wrong. I did tons of things wrong, probably more things wrong than I did right, but if you tell me what in particular I goofed up on, then I can improve it. I might be able to add different things to the course. I might be able to change different things. The cool thing about Udemy is you can actually go through and like make changes, add different content, and if you buy it one time, then you have access to all of the changes in the future, which is fairly awesome. So yeah, thank you guys so much for watching. If you're interested in the course, go ahead and check it out on Udemy. It is in the link below. I don't think I can add links to the little like top cards yet. But if you enjoyed this, share it out to your friends who are interested in web scraping. It's a super cool, like, kind of thing to do with programming. Yep. Thank y'all so much. Later.